So sorry. So that's the point basically. Rust is statically typed. It is secure. It is efficient in terms of memory management. It is very secure when it comes to handling errors. When it comes to preventing race conditions and basic programming errors that we are familiar with or that we are used to. So it helps to reduce those things. So you can actually write your code and be very confident that if I write this code, it should work this way, even without writing text for it. That's the point. So but let's jump into the code. We spent 70 minutes already, so we can just start something. So the syntax for Rust, most of us are familiar with it, like I said, because I'm sure that at least once in our programming journey now, maybe this year or something, most of us have picked Rust once in a while, either with writing smart contract or learning it or something. So if I make mistake, please correct me. I'm not an expert here. Thank you very much. All right. So to the guys that are just joining, welcome to the call. And yeah, so the point is, we are just trying to help ourselves. Like I said, so let me just give you a brief of what I said before. The reason for the class is we are trying to help ourselves learn Rust, right? As a group. See, you see this guy. So as a group, we want to help ourselves learn Rust because it's not easy to learn alone. That's the truth. And the truth is, most of us are not using this programming language every day. So it's not something you do and make mistake every day. It's not something you undo, task and you are writing and writing and writing. No, it's much more than just learning it on your own and writing basic calculators. As much as that will help you, it will not really help you as much as people that will use it every day to like create endpoints or write basic or write even more complex stuff, whether in blockchain or just normal apps or using it for embedded systems. You can't compare yourself in terms of knowledge. But if you try your hands on different things and with a group that I know that okay, they can help you whenever you have issues, it is easier. You learn faster, you can ask questions, you can get help. So, and who knows, from there, anybody can just get something up on Rust, maybe a job or a gig or whatever. And that's the point. So that's the idea about the class. So yes. And one last thing, please. Like I said, we are all here to learn. Even me, I'm learning. So there you get. That's the point. So yeah, let's start now. Finally, starting with the syntax, right? Rust is very in terms of syntax, Rust is very, very easy. Yes. And sometimes it can be very crazy. So, but the easy one are easy. The easy syntax are very easy. The difficult syntax are very difficult. That's the thing about Rust. So it tends to create that disparity between the difficult side and the easy side. But once you can grab the easy side, you can then begin to try your hands on the difficult side until you get it. But once you understand the simple syntax, the basic syntax, you can boast that you understand it forever. It's just that simple. So that's the idea with Rust syntax. So let's just start. The first thing we are used to from any programming language is comments, right? This is a comment. I know this is not big enough. Let me try to share my screen with this guy. Um, I can't create a new one. Just okay. Can't. Oh no, definitely not. Sorry, please. I want to use this online editor to try the Rust. This one too works, but I just want something else that can help. Uh, no, I can only download these guys now. Okay. So I'm coming, please. I want to use these guys, but I think my what they call it has expired, so I can't use it again. Let's delete this one. Delete this one too. Delete this one too. Okay. 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 So I think if I have this one, Sorry, please, let me just download this stuff so I won't lose them as I'm trying to do now. So I can delete this guy then. So I can delete this one too. Ownership. Yeah, Esther, please go ahead.
GM, good morning, everyone. Please, I want to ask if you can record it. Is it possible?
Yeah, it's recording already. I'm recording.
Okay.
So we can always go back to it. Okay, so I'm delete this guy to go away. Which one again? Okay, so I have 3 left. Should be able to use this one. Okay. Okay, so
Alpha, Natachi is trying to join.
oh really? Oh yeah. Okay, done. Atachi, welcome. Oh yeah. So I think it should allow me now. It doesn't allow me. Wow. So the thing is, I'm trying to just use this one to like test. I've not set up my personal local environment. That's why. So yeah, no. Okay. If my network is not acting up now, not now. Okay. So why this one is still, I think it's loading this one now, so I can know what is up. Shit. Should have loaded already. Okay. I think it's done now. So I still can't even work safe. Whatever. Okay. So basically the idea is I have not installed Rust completely. Like on my local, we still get to that point. I didn't want to install it. I want to show us like if in case you don't have it installed, you just do it, install it, start, and just continue from there. So, but basically, what we want to do is this is a right. This is what we have. So let me install this one as an app. Okay. Okay, so the first thing is the comments, right? So we are used to comments in most programming languages. At least everybody here understand how comment works. When it comes to like basic stuff like okay, I have this written, I have this written. Whether in Solidity, JavaScript, Python, whatever programming language, it's usually the same for all languages. Basically, it's either you have hash in case of Python, or you have this double slash. The double slash is common for every language. So it's the same with Rust too. Rust uses the double slash as comment, right? So it's the same as JavaScript or Solidity, all of those things. It's the same as what we have. So for functions, Rust maintains the same type of functions as you have in programming languages, other languages too, like JavaScript. So in JavaScript or Solidity, for instance, you have something like this. You can have something like get NFT, for instance, as a function like this. So in Rust, instead of the function as a complete word, you use the fn syntax like this, and you have something like get NFT too. It's the same thing basically. The only difference is the function as the keyword. So in a function, to use a function or to declare a function to say that, okay, I want this, whatever I'm going to write on this line to be a function, use the fn keyword. That's the keyword for Rust. Is a keyword, so you don't use it in your code as your own custom syntax. So it's a keyword, and when you do that, you specify fn, then the name of the function will come next of the function. So that's what comes next. Then you have the curly braces, which can take optional parameters. Then you have the curly braces, like as usual, as we have in other programming languages. So in that case, now we can say this is first class. And then you can say this is your parameters. The optional parameters in this case are just going to be maybe age, as students, whatever. So in this case, this is your function. Your function will take in one or more arguments, one or more parameters that you can pass into it. And that way, there are other things that you need to specify in your function. So like you have the return type, you can specify the return type, just like you have in Solidity, whereby you have something like function, like I said the other time. You can have something like this, get NFT, like this. You say public view, and then returns something. In your return, you can have in 256, right? In this case, now you're expecting that it should return this data type for you. In the case of Rust, you are specifying that return type using this arrow. So in this case, you can specify it in 256 also. It's similar to other programming languages. So it borrows a lot from different languages. So if you are used to other languages, you can easily get familiar with Rust. Like I said, the basic syntax are very basic. The complex ones are complex, but if you understand the basic ones, you can now transition to the complex syntax, and then you just keep trying them until you get familiar with it. That's the idea. So in this case now, if you have something like this, I have this type of function in Rust. What it means is this function is called first class. It takes an argument of age, and I'm expecting it to return a int256 for me. That's basically what this means. So this is an example of what a function is, and you can see an example of the function here too. We have a function called main. Main in Rust is the entry point to all the programming, all your programs, all your functions, the program generally, your project that you scaffold using, whether you use Cargo or whatever. So main is always the entry point. So you can also change that to custom entry points, but for the default and for convention's sake, main is the entry point for your Rust programs. So that's what you have, and basically that's the idea. So now let's look at this. According to this place, now I say functions in Rust are defined in the fn keyword. Yes, yeah, we said all of these things, and you can specify the return type too. So we have something like this: function name, input parameters, return type, and the body. That's the syntax. So basically, when you have something like this is the syntax for a function in Rust, right? So I'm not putting that here. So then, looking at this example, now let's try to translate this. It basically means I have a function that I'm declaring using the fn keyword, and the name of the function is greeting. This function is not taking any parameter at all, right? But it's returning something, and it's returning what? A string. And that string that is returning now, I'm specifying that string as a reference. That's what this ampersand means. And I'm using a lifetime for that. Don't worry, we'll talk about lifetimes later. So we are not dealing with that now. But basically, this is just a syntax for lifetimes, right? And then we are using this static. But let's not do more about this for now. We just know that this is a string, right? It's returning a type of string and a reference to a string. That's what it's returning. So it's returning a reference to a string. That's what this. So if you have to translate this function, that is what it means. You have a function that is returning a reference to a string, and that's the idea. So yeah, so that is that. So now we can test this. We can try to run this code, but we are not running anything yet. Let's just try to understand the syntax first. So greeting has no input parameters and return a reference to a string slice, exactly, to a string slice. So let's assume this is a string, right? It returns a reference. This function returns a reference to that string slice. So that is what we have for how to declare a function. So for the return type, basically, if you specify no return type, like going back to this, if I don't specify it to return anything, like in this case now, this does not return anything, right? So because of that, I can just pass in anything to the function and it will just execute this function and give me the result. But in this case, if I write something like this, let's say I write this as let me remove this. We're not using the parameter, and I'm returning false, for instance, it's going to not work, right? So, and the reason why it will not work now, basically, because the idea is I want to return something, right? I want to return a value. So if I return false, for instance, this should not work at all because I'm saying that I'm going to return a unit type, but I'm returning a Boolean type. So this should fail, right? Where is it? Exactly. So it should fail in this case because okay, this unit itself doesn't even work. But you don't worry, you get the idea, Sha. This is a unit type. You still come back to do the right thing. This is a type of integer, but we are returning a type of Boolean. So this is just to like explain what you expect on a normal day for this thing. So going back to this. So now the return type, using this same one to explain. The return type, if you don't specify any return type, you cannot return anything from the function. If you do this and you return something is wrong, I can't return anything from this function also. But for the entry point function, you can actually return something because it's an exception. But for a function that you create yourself, you cannot return if you don't specify it to return anything. If you do that, you are likely expecting an error.
Sorry, please come again on that part.
Okay, so I'm saying that is it for the main or for this first class?
Which of them can you use return and not for?
So this one does not return anything. So like if I have a, no, let me not use that one. That's an exception. If I have something like this function does not return anything here. This one, because I did not specify to return anything here. I'm not specifying a return type like this. You get? So it's not expected to return anything. But this one is expected to return something. It's expected to return a unit type. This is not the syntax for units, whatever. So it's expected to return a type of integer. That's what it's expecting for this in this case, right? So if I run this now, it's not supposed to work because it's expecting an integer type, but I'm returning a Boolean. I'm just giving this as an instance. So I'm basically supposed to return something, whether I return something like 1, like this. Do you get now? So that way it matches the return type here. But in this case, I'm not expected to return anything from this function because I'm not specifying it to return anything. Just like you have in Solidity, where you want to return, you have to specify returns so and so. Do you get? Does that make sense? Hello?
Yes, it does.
Okay. So now, so there's something we also need to understand about return types. Now that we are still in function, I can.
Sorry.
Okay.
Sorry. The return, is it compulsory? Like that keyword itself?
No, it's not. That's where I'm going to now. So you can do without it. So in this case, I'm trying to show something now. So in this case now, I'm returning a unit 8, right? Like the way I'm showing this now. So let me show this as an instance. So I have this first class function returning an unsigned integer type of 8 bits, right? And I can, like I said, if I can return it like this, just 1, or I can return it like this. They are both valid, like 2 of them are valid. In case I do this or I do this. The reason why this is valid is because it's the last sentence, it's the last block of code within the body of this function. So if I use 1, I'm simply saying that this is the last line of code in this function. So take it as the return of the function. Do you get? So now, Sam, to answer your question, what this means is that I can specify the return type without using the return keyword. But note the difference is that I'm using semicolon here, and here I'm not using a semicolon here. That's the major difference. And that is important because if you pass a semicolon here, it's going to fail. Do you get? If I try to run this now, see, it's going to fail. It's going to fail like this. You can see this. Oh, Jesus, are you kidding me right now? So it's going to fail. Like if you can see that this is returning an error already, so it could not compile this due to previous error. And the previous error, if you check it out, It says expected unit 8. That's the return type, but found this. So this is the non or type, or the option type rather. This is the option type in Rust. So we'll talk about option type later, but because I'm passing this now, but if I don't use the semicolon and I run this, right, it's just going to work. These are just warnings because I'm not running the class, I'm not doing anything. So it will work as expected. So there are two ways you can return this. You can use a return. You can return a value from a function. It's either you write the value as the last line of the code of the function, rather. It has to be the last line. If anything comes after this, like this now, if I say something like this, if I to throw 2 errors, the first error is going to throw is that this doesn't have a semicolon. That means you are not terminating this line. The second thing is that it's not returning anything. So if I run this now, I'm going to get 2 errors from that, right? Exactly. So you can see expected semicolon found this. So that's the first error. Then the second error is going to be the mismatch types. That's the type is not even correct. So that means you are not returning the expected type. So those are the 2 errors you will get. So when it comes to return statements, when you are returning, you can either return the value of the actual type of the return that you define here without the semicolon, or just to be safe, use the return keyword and just do like this, and you are good to go. So if I run this again, everything will work as normal. Does that make sense? Okay, so I think this answers your question, Sam. So that's another way. These are the 2 ways to return in Rust. You can either use the return keyword, or you just return the value without using the return keyword and without specifying the semicolon. And that way you have everything you want. Everything is just set. You have the function name and everything will run fine from this place. So those are the 2 ways to return. So that's basically what they're talking about here, returning values. So one way to return values is the 2 ways to return value is either use the return keyword, or you just return the value directly without using the semicolon. So in this case now, we call this implicitly returning values. So basically this means you are implicitly returning implicit return, and this is explicit return. Explicit in the sense that you are explicitly saying that this is a return. You are using the return keyword. So because you're using the return keyword here, it's an explicit return. But because you are not specifying the return keyword here, it's an implicit return. It's just English. So mind it. So that's the idea. So but it is considered idiomatic to omit the return keyword when possible. Because if you see any Rust code, you will notice mostly that you will see this kind of syntax. At the last line, especially for functions that return something like this, you will not see a semicolon at the back. You just see something returned on the last line. No semicolon, no return statement. That's all. That's what Rustaceans prefer to use. It's just a convention. But that doesn't mean you can't use your return your own. It's just your choice. So now let's talk about input parameters, right? So talk about parameters. For a function, remember the syntax for a function. It takes in the function keyword, the function name, like we said the other time. We have the function name like this. We can have first class like this. A function name, we just call the function name. Then the arguments. Then we have the return type. Then we have the body of the function. So this is syntax basically. So now let's look at arguments, right? So we've seen the function name. So the convention for function names in Rust is to use the camel case actually. So you don't, in the way I wrote it before, using this, don't use this. Is it camel case? They call it just snake case now. I think it's snake case. We don't use this kind of syntax by convention. It's not, there's nothing wrong with it, but if you are running it on VS Code, for instance, that has a Rust linter, it's probably going to flag it as an error and tell you that, as a warning rather, and tell you to use the default or the preferred convention, which is having underscore between 2 words and just writing it like this. So this is valid. So the same thing with, it follows the same convention with Python in terms of naming functions and stuff. So, but JavaScript uses something different. JavaScript uses something like this, or Rust uses something like this. So just a convention. So but let's talk about the arguments now. Let's use this another function to pass in an argument. So in this case, the argument I'm trying to run I want to like take in for this function now. What is that argument? So let's say I want to take in an age of U8, right? And I want to return that U8. So I can just do like this. This is a valid function, right? Get and return age. This is a, let's say this is a name. This is a function, right? And when I'm passing this function now, let's say I want to say get and return age as 4, like this. By the time I run this function, this one, let me comment this out so I won't get those warnings so it can be easy to read. So by the time I run this function now, I'm going to get something like this: hello world and age. In this case now, this is just because I'm not console logging anything. I can't see the return value, right? But if you say, let's say I want to console log it now and say red result equal to this, and I say print line, the age is how did they run this thing again? So, okay, press like this. By the time I run this function and I run this, we'll get the age that is used. So the age is 4, right? So in this case now, what I'm simply doing is I'm passing in different parameters. I can pass this as 10 now, and when I run my function, it's going to be 10. So the idea is just the same way we have a function where you can pass in the parameter, like in JavaScript, for instance, where you have something like get name, and then you say name equals to string, maybe in TypeScript, and then you do something like this, return name. This is the same thing as what we have here. We have a function name, we have the function keyword, we have the function name, we have the parameter to that function. In this case, it can be more than one, right? We can have name also as string. It's still the same thing, it works. But here we have a name called get name here. It takes in a parameter of name as string. That's for TypeScript now. I'm just using this as an example for TypeScript. And then you return the value. The same thing you have in other programming languages is the same way. It's just that this has a lot more verbosity, in the sense that you need to specify the type from start to finish. So in this case now, I have get and return age, and I have the age as uint8, which means I'm only expecting an integer type not greater than 8 bits. So that means it must not be greater than 2 raised to the power 7 minus 1, 2 raised to the power 8 minus 1, 2 raised to the power 7. So the highest value it's going to take for this is 255 for this. So all of those stuff, we'll talk about them when we get to integers. And this takes in also a name, and I'm expecting to return an integer type also, which is the age. So in this case now, don't forget that I can do this also, right? It's totally valid, but I can also do this. But as a Rustacean that you guys are, this is how you probably want to write it all the time. And I don't know if that makes sense.
Excuse me.
Okay.
When you specify the type of name to the string, right?
Yep.
That and ampersand in front of str doesn't mean anything. Could it be without it or this?
No, this one has to be like this because you are taking a reference to the string. So because manipulating strings in low-level languages are always problematic. It's not like in high-level languages whereby they've done a lot of stuff for you. When it comes to low-level languages like Rust, the way you manipulate strings or the way you handle strings, not just Rust alone, C++ and C and Rust, those 3 languages or any other low-level language, when you manipulate string, you are not taking that string as it is. You are probably making reference to that string. It's only in few cases that you can take the string and do whatever you want. But the normal thing you probably want to do, and for all your string manipulation in Rust, is probably to use it as an ampersand string. This way, you are saying that give me the reference to this string, right? So that I can make use of it here. Remember this stuff I showed at the beginning too. There's this one here. You can see that they are still using this same ampersand sign. So you are saying that give me the reference to a string. So whenever you see a string, mostly, in fact, in most code you will see, whenever you talk about string, it's going to have the ampersand sign. Yeah, then what that means is give me a reference to this, whatever you are passing to it is what I want to make use of. And the reference means that you are not taking the string as it is. You are just making a copy of that string and making use of it. But that's not the literal meaning, Bob. When we get there, we'll talk about the literal meaning. But that's the idea. You are just saying that I want to use that string, but I don't want to use the original string. There's a lot of things why, there's lots of reasons why we do it this way, like why we use the ampersand. But that just for now, just know that you are making a reference to the string. because the idea about strings is a lot. Strings are very difficult. They are bytes, but they are bigger than bytes. Then you need to split it, and they are very heavy to manage, and they are this and that, and blah blah blah. But just know that this is how we take it as a type for a parameter or for a return type. So if I'm also returning this is probably what I will do. You get. But there are other ways to use string in Rust too, or we'll get there eventually. So does that answer your question? So taking a parameter of U8, that is max of 255, and taking a name as a string. Yeah. Reference to a string. So that's the idea. And the third thing is return a uint8 data type, which in this case is age. Voila. So that is, so you can see this function as simple as it is now, just this function. You can see that we can dynamically now use it in the main function, and you can pass in 100. But if I pass in something that is greater than the value, also greater than U8, it's going to fail. Right? It's going to fail because what is it? Oh, sorry. I was supposed to not do this. So if I what am I doing? Okay, so if I do this again and I run this, so this is going to fail because the data type is different now, right? What is happening? Getting it. Am I even getting it? Oh, shish. Yeah, so you can see that it's telling me that it's out of range for U8. So like I said, the max is 255, and 255 is because of 2 raised to power 8 minus 1, the normal bit management, memory management stuff that we have. So in that case now, you cannot use 1000 here, right? You cannot use 256. In fact, it's going to fail. So if you try using 256, it's going to complain too because it's greater than the value. Do you get? So all of these things now allow us to know that this allow us to infer. That's basically the idea. This data type now, Rust already understand that once it is U8, the maximum value you can have cannot be more than 255. Once it's more than 255, it's a problem, right? So if I make it 255, it's going to work. It's more like that overflow error that we always experience in Solidity if you write your code, overflow and underflow and the like. So that's the point. And so that means we can have beyond 2 raised to power 55, 255, 2 raised to power 7, and that is 2 raised to power 8 minus 1 rather. So that is what we have here. So that's how to define a function, or using a function with parameters and with return types. That's all. Yeah, so I think we are done with functions now, right? So yeah, so let's see this. Since we've been mentioning types a few times, blah blah. Rust is a statically typed language. Yes, we've already established that it's statically typed. If you look at everything we've written since, all the things we've written here, you can see that it is statically typed. We are always specifying the type that we are expecting or the type we are returning. In this case, we are expecting a type of U8. We are returning a type of U8. So we are specifying the type. So that's what they mean by it is statically typed. Now, every single value in Rust has a type, and that type must be known to the compiler at compile time. So I forgot to mention, Rust is a compiled language, right? So every compiled language, in fact, every single one, always make use of types. Like they are statically typed, they are strongly typed, because they need to be able to make decisions about your code before running the code. So when they compile the code, they want to know if there's an error or there's no error. And one of the ways they do that is using this typed preference. They want to know what type you are trying to run and if it is valid in terms of the grammar side of the language. So these are a form of static analysis that is handled by the compiler. So that's basically what they mean by static analysis. The ability of the compiler to be able to infer or determine if the type that you are using for your code, mostly the type actually, is correct. So that's one of the functions. So you can think of a type as a tag that the compiler attaches to the value in your program. Depending on the tag, you can enforce different rules. You can add a string to a number, or you can You can't add a string to a number, but you can add two numbers together. So if leveraged correctly, these types can prevent all classes of runtime bugs. So the idea here is that, excuse me, when you have your, so when you have the type, right, and you specify the type, you want the compiler to make use of it and to know what value to use, whether it is valid or not for the grammar, because it passes it to a grammar. All of those stuff that happen in compiler stuff, that's what happens next. So, so now let's look at the exercises, right? And it is inside. I think I've opened the exercise already. So the exercise is located in this place. So the exercises for this code, and that's why I chose this one. So the exercise here is just to but it's basically just what they call it, just libraries though for tests. That's what the exercises are. So you can have a function like this, and then you can have the test here. So these are just exercises, and just to show you what we have been talking about since. But you know that this is wrong actually. And what is wrong in this? If we check this now, we can see that this is wrong because we are not specifying the type, right? So if they tell you to fix this type of code now, you know that the first thing that you should notice, the first thing that should come to your mind is, I need to type every parameter within the code. So the first thing you want to check is check the function syntax. Is it correct? Yes. Check the function name. Is it correct? Yes. Check the parameters. Is it correct? No, because this doesn't take in the type. So you need to specify the type here. And you need to also specify the type here. And by doing that, you can then manipulate this. So if I run this now, also, let me see, compute 5, 3, and 5. So if I pass this is valid now because I've already specified the type. So now that way we've already solved the first exercise in this GitHub now, because it was not working before. But now if you do this now, I will put the type like this, then it's going to work. It's going to be valid. And now let's test this to see. Compute value is true. Now if I run this, I'm going to get this value. Oh, sorry. What is the problem? Okay, U8. Okay. This is due to type problem. Okay. Okay, let me just change it back to U8. We don't need that. U8. If I run this, so I can get the value to be this. Now, the reason why it was throwing the error before is because I'm using two different types. Yeah, I can typecast it. Yes, that also works. But because we're using U38, 32 here, and we are returning a U8 here, the reason why that field is because this and this are U8, and they are smaller than the U32. There's a lot of memory stuff that, like I said, Rust manages memory well for you. So it prevents you from making some stupid memory mistakes that you should not make. Now, it might not make sense to most of us now. The reason is because for every program you write, there's a memory space allocated to it. There's a memory, there's a virtual space called the memory space. And that space is used for the runtime of your code. So in this case now, Rust already knows that, okay, you are using U8 here, you are using U32 here. It's allocating U8 for each of these arguments. But you're now saying you should use U32 as a return type. That way, it's going to look at it that, okay, it's a waste of space. So why do I need to do that? It's going to tell you that it's not possible. It's going to flag it for you. And that's because he has already created that for you. And he knows that by inference, don't forget that because of the type, the compiler can make inference, static analysis, and say that, okay, will this thing work successfully? Is this efficient or not? And that is why people prefer us, because it prevents you from making such stupid mistakes. So that instead of you using like 2 megabytes and you're already specifying it to return U32, it's going to allocate 4 megabytes to it. So that's waste of space. That's just an example, right? So in that case now, Rust to prevent you from making that kind of stupid mistake, but enforce you to use the actual memory space. But if I convert this to U32, for instance, like this, now everything is going to be valid and okay. Because in this case, I don't have a problem because they have the same type. So it simply means I'm saying that allocate U32 as a space. That's 32 bytes, 32 bits for the parameters and allocated 2 bits for the return type. So because they are the same return, they are the same size in terms of memory, there's no problem. So that's why it was throwing the error the other time. So all of those things are one of the reasons why Rust is preferred in terms of managing and writing proper data. So that is that for syntax.
Yeah.
Let's run. Okay.
For I know that the way you are returning works that way. That the value is curly brackets, then comma, you now put the rest outside. Is there an alternative way to write that? Can you also write it like, oh,
This.
wait, no, what you are printing?
Oh, you mean this one?
Yeah, the way you are printing it, like the age is curly brackets. Then
Yeah, this curly bracket is just make reference to this.
there an optional way as well. Can you just write the age is rest directly without putting the curly brackets?
I think, does it work this way? Nah, I don't think it works out. But there are different ways. But this is one me I use. Like I said, I don't know everything here.
Like-
Guys, is there any other way? Anybody that knows me, I don't know. But this is one I use. Print line, just print line on this, because I'm familiar with this syntax a lot, so I stick to it. I know there's a way people tend to write it. I don't know if it's a print something or print format or something. I don't know. I think it's print F or blah blah. There are different ways. Probably they use libraries, so I don't know, but this is the one I know. So you can look that up. If you find it, feel free to drop it and explain to us, or drop it on the group later, so you can learn from that. Here you get. But another thing to mention is that you can specify different parameters here. Like I can do this also, as long as whatever I have inside here matches the number I have here. So I have 2 curly brackets inside here. I have to have 2 parameters here. If I have 3 like this, I need to have 3 for some reason, like this. I don't know if that makes sense. So that's that. So yes, so that is basically functions. So that this is just functions for you. Everything about functions. That's it. So let's go into integers sharply before, and then we wrap up for today. Let's spend 1 hour plus by then. So now let's talk about integers, right? So we talked about types and functions. From this, I've mentioned types also. So we've done a bit of type. We've talked about type a bit, and we've talked about functions, and I've shown you print lines. Even though I didn't talk about printing anything here, I just wrote it, but we'll talk about it. So then we have the types. Let's talk about the integers now, right? We are going to create a basic calculator here. And yeah, so what that is that in this chapter, we'll learn how to use Rust as a calculator. It might not sound as much, but give us a chance to cover a lot of Rust basics, such as defining and calling functions, which we have already done and seen, declare and use variables, which I have written, but I have not explained, like this, and primitive types, integers and booleans, which I have talked about, integers, and I've used boolot also. Arithmetic operations, including overflow and underflow, I've explained a bit about that. Comparison operators, we've not talked about it. Control flows, we've not talked about it. Panics, we've not talked about it. So this, by the time we cover this whole chapter of calculators, and from here to here, you should have an idea of how to use almost all the basic data types of Rust. And don't forget, like I said, the Rust-based syntax are basic and they are complex. The basic ones are simple to know. The complex ones are not simple to know. But once you can familiarize yourself with the basic one very, very much, you can always transition to the complex ones. It just takes a bit more work and a bit more consistency. And then you can easily understand the complex part of it. And once you grab the complex part of it, you can write anything in Rust. It's just like any other language. Solidity, JavaScript, CSS, HTML, Python, whatever you can think of. But you need to know the syntax first. And it can get tricky with Rust because there are a lot of things that you need to know in terms of the syntax. So it's a very verbose language. That's the point. So now let's jump into this stuff, Sham. Enough of the old talk and talk and talk. But nailing the basics with a few exercises, we get the language flowing under your fingertips. And when we move on to more complex topics such as traits and ownership, we have to focus on the new concept without getting bogged down to the syntax or other trivia details. So like I've been saying, once you understand the basic ones, the complex ones, you can then keep trying and trying and trying. Of course, you will get errors, you will get bugs. It's difficult to start, yes. But for most people, they pick it once. So most people, not every time, but that's the point is we are all learning. So we pick it at the same time too. So that's the flow. So now let's go into integers sharply and talk a bit about integers. We just run through this, then stop here, then we'll continue in the next class. And we just pick the exercises and play around with it. So the first thing to know about this is now remember we did this compute, this one that I did here, this compute function, and we've already fixed it here, right? So that's what they are making reference to here. Now, so they said if the input parameters were of type U32, let's unpack what that means. So U32 is one of Rust primitive types. So primitive types are the most basic building blocks of a language. They are built into the language itself. That is, they are not defined in terms of other types. Now, you can combine these primitive types to create more complex types, and we'll see how to do that soon enough. So all of these things we've done here so far are primitive types. We use primitive types all through the code we've written here. So I'm just going to give a lot of space, and let's talk about primitive types a bit. So now let's talk about integers, right? So for integers, let's start with integers. Reduce this. So we have for integers, right? We have this. Integers are of two types. So the first type, we have the unsigned integer, and we have the signed integer. So we have these two types, unsigned integers and typed integers, signed integers rather. So U32, whenever we use the word U something, so unsigned integer range from U8, U1, let me use that word, to U, I can't remember the max now for Rust, but I shall know that we have a lot of U. So whenever you see U now in integers like U8, U16, U32, 24, U32, U48, U this one and that, blah blah blah, U256. You get the point. When you have U256 like this, all of them, as long as there's U at the front, is an unsigned integer. And what unsigned integers mean is that you have, so you have they can take signs. What do you mean by signs? They can take positive and negative values, right? But those are unsigned integers. What am I saying? Sorry, they cannot take, those are signed integers rather. Unsigned integers cannot take those things, right? They cannot take signs. That is, they can only be positive values. So, but for unsigned integers, for signed integers, they can take positive and negative values. But unsigned integers, whenever you see U whatever, they cannot take negative values. Now, let's even test that here. Let's change this to minus 255 here, because we're using unsigned integer, don't forget. So if I run this now, do you get now? So you cannot apply unary operator minus to this, right? Because unsigned values cannot be negated. Do you get the point? So when it comes to unsigned values, you cannot use negative values. It is forbidden. Let me use that word, forbidden. You are not permitted to use negative values. So are we together, please? Hello? Okay. All right. So we are together. Fine. So yeah, so that's the point. So the idea is you cannot have what do they call it now? You cannot have signs for unsigned integers. You can only use U something, U8. Once you have U at the back of it, it simply means that you cannot take negative values. You can only take positive values. So let me remove this negative from here, and we are back. So now that's what you need to understand about unsigned and signed. So the U here means what? Unsigned. That's the meaning of the U. And when you the other ones which are signed integers, we have things like I8, I16, I24, I32, I40. I'm just 48. I'm just 48 and I256. So in this case now, these ones we take positive and negative, just opposite of unsigned. So Now let's look at what this means, right? Only when we talk about this 8, I mentioned the other time that this is 8 bits, and I already explained why and what it means. 8 bits in the sense that you cannot have more than something like this. 2 raised to the power 8. 8 bits memory space equal to 255. Starts from 0 to 255. Now the reason for this is because it's 2 raised to the power 8 like this minus 1. So 2 raised to the power 8, which is equal to 256 minus 1, which is equal to 255. So that's where we have the value range from 0 to 255. So when we have 8 bits, when we have 16 bits now, 16 bits memory space simply means 0 to 512, I guess, or something. I don't know, but just know that the value is 2 raised to the power 16 minus 1. And 2 raised to the power 16 is what? Boy. 65536, right? Minus 1. So it is 265535. 36 minus 1, which is equal to 65535. So this is the maximum value you can have for 2 raised to the power 16. You can see it's already big already. So it's already bigger than what you can expect. So 2 raised to the power 8, like we said, is 256. 2 raised to the power 16 is 65536 already. So you can see the difference in size. So by the time you are specifying 2 raised to the power 256, you can imagine the number. So, but this is the maximum number we can have for 2 raised to the power 16. This is the maximum number we can have for 2 raised to the power 55. And 2 raised to the power 8 rather. So this 8 and the 16 and 32, 24 that you have here is just the bits, the number of bits that you have that is going to be allocated for that memory address. Right, so that's basically the point. So when we have the 8 and we have the 16, we are simply saying that okay, the 8 means I'm using 8 bits, the 16 means I'm using 16 bits address and memory space allocated for that variable. So that's the idea. So yeah, so that's what it means now. These are for unsigned integers though, right? For unsigned integers. For signed integers is a bit tricky because it is from the negative value to the positive value. So but what you need to understand for the
Minus.
You said
I saw minus 2.
minus 2, no, minus 2.
256 minus 2.
To be minus 1 here. So I'm just explaining how this becomes like this. So yep, so that is that. Yeah, this guy has joined up. Did I add him? Yeah, did I add him? Yes. Okay, so we have 256 minus 1, 255. We have 65535. Yeah. So then basically this means the maximum number you can have for 8 bits, right? From what we've explained now is 255. The maximum number you can have for 16 bits is 65535. So by inference, whenever you use unit 8, the maximum number you can have is 255. And I demonstrated it the other time. If I put 256 here, it's going to fail, right? If I use negative, it's going to fail because it's not allowed. So these are for unsigned integers now. So for signed integers, it's a bit different in the sense that the 8 that you have here, the 8 bits memory space is not just 2 raised to the power 55 alone. It's not starting from 0 now. It's starting from negative 255 to 25, is it 254 now? 25, I don't know. It's just starting from something, but I can't remember, sorry. I should know that it's starting from negative. It has negative values and positive values, right? So it has minus 2 raised to the power, I think it's negative 256 to 255. Yes. So this is how it's going to be, right? For the signed integers, which is the normal one like I8. So in this case now, I8 means you have something like this. I16 also something similar. So I16 in this case too is also something like minus 65536 to 65535. That's the range that you can have. I hope this is correct. I don't know if I'm saying the right thing, but this is what it means, right? So if it's not correct, I'm sure okay, yes, so this is something like this. Yes, actually correct. He's wrong, I'm wrong in this case. But 2 raised to the power 31, yes, so it's wrong. So in this case now, if it's U32, right, you can represent the number as 0 to this. So like I was saying, the max you can have for unit 8 in this case is 255. I bet you should correct me if I make mistake. Oh, I don't make one blunder already. So let's calculate again. 2 raised to the power 2 raised to the power what? 7 close to 128 exactly. So this should be 128. Sorry, 128 to 127, if I'm not mistaken. Yes. So this should be 2 raised to the power that's 15, right? Which is 327 what 68 to 32767. So just subtract one from here and add it to subtract one from this and it becomes the value here. So all of these are just the calculations of what's the range you can get her. So in this case now, if it's I32 now, I32 in this case, I32 in this case now is simply 2 raised to the power. Let me just write that out. So I'm calculate it. 2 raised to the power 31 minus 2 raised to the power 31 to 2 raised to the power 31 minus 1. Like this. So that's how I was able to calculate this. This is 2 raised to the power 7. This is 2 raised to the power 7 minus 1. So that's for signed integers. So for signed integers, the values are quite different in terms of what you can have, right? So if I do something like this, just to demonstrate what we said here, if I do this and I do this, right, and I run this function now, what do you think is going to happen? It's going to say it's not possible. Why? Because 255 does not fit into the type of I8, whose range is what? -2, minus 128. Like you see what we have here, right? So minus 128 to 127. So that means you can see that there's a limit to what you can now have if you are using signed integers, because it needs to accommodate for the negative side of the number line. You get? So that is why we have this. So if you have no need for using negative numbers, it's good to just stick to unsigned integers. That way you have more positive space to allocate to your values. Oh, well and good. So that's just the idea about the 8-bit, 16-bit, 32-bit, signed and unsigned stuff. So now you can calculate what's the value of, if you have to calculate now, you know what the value of I128 bits will be, right? You already know that it's going to be minus 2 raised to the power 127, right? And to a range of 2 raised to the power 127 minus 1. So this is going to be the range. You already understand that. So by the time you calculate, you get a very large number, and that's the value. So that's that about the signed and the unsigned stuff. And then we have literals. Now, what are literals? Sorry, I hope this is clear enough. This is what I explained there. Any questions for this? Any question, please? Is it clear? I hope we are not lost. Are we together, please? Okay, clear. All right, thank you. It's clear. Okay, so let's see. Let's see. Sorry, literals now, right? Yes. Look at mine. So we have literals. So for the literals, we have a literal is a notation for representing a fixed value in source code. For example, 42 is a literal, Ross literal for the number 42. So so let's go about this. Don't need to stress yet about this. So type annotations for literal, but all values in Rust have a type. So what's the type for U42? The Rust compiler will try to infer the type of a literal based on how it is used. If you don't provide any context, the compiler will default to I32 for integer literals. If you want to use a different type, something, you can add the desired integer type as a suffix, e.g. 2 raised to the power 2U64, saying that this is 2, but as a U64 type. Don't worry, we'll talk about this eventually because we need that also. So there are times you want to you don't want to specify. What they are basically talking about here is there are times you don't want to like specify the type, right? So in this case now, if you don't provide the context, the compiler will default to I32 for integer literals, right? If you want to use a different type, you can add the desired integer type as a suffix, e.g. 2 raised to power u 2u64, which means that this 2 is an unsigned u64 unsigned data type, right? So we still use that. I don't know. Let me see if there's a way we can use it in any of the functions we have already. So then there is none. There is none for now, but okay, we can use something like this now. You can say let's padding equal to 2u64. Now in this case now, I'm returning the age. So what it means that whatever I add to the age now, don't worry, this is not going to work, sharp, but whatever I add to this age, whatever I pass to age rather from here, I'm going to be padding it with extra stuff here. So if I run this, it's going to fail, like I said, it's not going to work. So because I have two data types, don't forget what we said the other time about the memory sizes that you specify. This is U8, right? You are expected to return U8, but you are adding to a U64. So obviously U8 is smaller than U64, so it's going to fail. That's already a memory breach. It's a memory error. So what I can do here is convert it to a let's see, U8 is still correct. If I do this now, it's going to work well because you understand that 2 is a U8 type. Oh, it did not work. Oh, attempt to add it overflow. What is the overflow here? Yeah, oh, error don't
What?
come. Oh.
Why are you adding 2 in front of the US?
No, am I adding what? This.
2.
You mean this?
Okay. The 2 in front of the US.
No, the U8 is the type. The 2 is the value for padding, actually. If I do this now, watch. It's going to, I'm just trying to show you how to like use, oh, sorry, I know what the guy is feeling. I'm just trying to show you why, or how to use this U8 because it's a literal, right? You're just trying to, in case you don't want to specify something like U8 here, like this. That's what I'm saying. Do you get now?
Yeah.
You can just use it like this instead. So I'm just trying to demonstrate what they are talking about in terms of type annotations for literal. In case you see something like this, it's still speaking to the same thing, it's just a different way of writing it. And as I say, like you have to understand a lot of things about Rust. There are a lot of similar things that are done different ways. Do you get? So that's the point. So in this case now you have padding as 2U8. It won't work because it has done, there's this overflow. You are using 255 here. So let me change this to 200. And if I run this now, it's going to work. Do you see now? So the value is 202. Why? Because I'm adding this padding to it. So the value I pass is 200, but because I'm padding it with 2 here, right? There's a way I could have written this as U82, right? In fact, I can do it without writing anything. It will still get the value. And I can decide that I want it to be a U8 value, right? And it's still valid. But in case I don't want to do this, I don't want to specify the type. This is not the best way to use this underscore U8 thing. U8 stuff. There are times you use it when you want to, it's more like for typecasting or for making inference. It's more like for casting, sure, but we'll come there. I'm just specifying just to show you that you can also use it like this without specifying the type for the variable directly, and it will still work well. Right? I don't know if that makes sense. So that is so that's that about this.
I have a question.
Okay.
So we can actually use any number aside from that two that you attached, that you padded.
Yeah, I can change it to 14. In fact, it's just this is just an example. So if I do this now, the value here will now be 200. Now I'm passing 200 here, but it's now be 200 plus this 14 here. This is just a number. U8 here is just the type, right? Don't forget.
Okay.
Yeah, so if I run this, it will be 214 instead of 202. Do you see it? So it's just a number.
What's if you pass something like an int, maybe like minus 20 I8? I want to see how that work.
Minus 20 like this.
Yeah,
it won't work because don't forget that we are returning a U8 type.
Oh yeah.
Exactly. So okay, this should work actually because we are subtracting, so it's not going to underflow. So, but yeah, it's not working. No implementation. Okay, yeah, because we're adding I8 and U8 together. So except we now typecast this back to, sorry, this is not to typecast it. Except we now typecast it back to U8, right? I don't know if this is going to work, Sha. Yes. So it's not going to work, but there's a way we can typecast it back to U8. So I think when we typecast it, I don't know if this is accepted. I don't have a reason to do that. Yeah. So when we, if but there's a way we typecast, right? When we get to casting, I forget. I can't remember how they do that casting again. But don't worry, when we get there, we can now typecast this back to U8 type, but it's still not going to work because this is an integer type, not an unsigned integer. So it's not going to work. Yes, it's not going to work. So that is that for now. So any other question? Before we move forward and try to wrap up this guy. Okay, so I assume there are no questions. Yeah. So if there are no questions, let's move on to underscores in literals. So there are times you see underscore like this, right? You see 1 million written as, you see something like 1 million written as, let's say you want to write 1 million like this, right, with 6 zeros, right? So if you have it like this, it can be confusing, but Rust allows you to specify underscore for literals so that you can understand how many zeros or how many digits they are. So by the time you do all of those things, it's not going to have any effect on the code. It's still going to work normal. So you don't even need to bother about it much. It's not going to have any effect. It's just going to work as it should work. So this is still the same thing as having let underscore equal to 100 over 6. So these two are still the same thing. They are the same actually. The underscore is just for readability's sake. That's all. So now let's talk about the operators, the arithmetic operators. So in this example, we've used plus, we've used multiplication. We can use negative, minus, we can use division, and we can use the modulo sign for remainder. So yeah, these are the arithmetic operators you can use for integers, right? So let's say in this case now I can say minus 1, then modulo 2. It's still, all of these things are valid as long as I can use all of these things: addition, subtraction, multiplication, division, and remainder. So this remainder is just to get the remainder of whatever you are dividing, right? So just the modulo sign. Most of us are familiar with that. I'm sure we are familiar with it too. So precedence and associative rules for these rules are the same in mathematics. So just like you have BODMAS, right? Times comes before plus. Exactly. It's the same structure here. Okay. So yeah, so I'm sure we are familiar with this also, that when you divide, just like you have in Solidity, that you cannot divide integers and get decimals, right? In Rust, there is similar syntax, but it's different a bit, in the sense that if I try to divide two integers, I can't get a float, or I can't get a decimal type, I can't get a float type. No. I will always return an integer type. So what I mean by that is if I try to say something like print line this division example, I say 5 divided by 2. In this case now, normally it should be 2.5, right? But if I run this, it's going to give me 2, not 2.5. The reason for that is because it's an integer type, right? And integer division using this sign is not going to give you the remainder in terms of decimal, because by default, Rust expect that because they have the same data type, that's 5 and 2 have the same data type, the data type that should be returned must be of the same type too. So it's expecting itself to return an integer data type. So it's not going to return a float data type or a decimal data type. Just have that at the back of your mind, because you can make your code go crazy when you're writing it. And then you notice that I'm dividing, but I'm not getting the right answer. Just know that when you do that using this division, you are not going to get the remainder of that division. So there are ways to catch those things, but just have that at the back of your mind. There are things to note. So no automatic type coercion. So Rust, as we said already, is a statically typed language, right? So In particular, Rust is quite strict about type coercion. It won't automatically convert a value from one type to another, even if the conversion is useless. You have to do it explicitly. And we've already seen errors about when I was trying to use this one as integer, right? Minus 20 I8. It failed because Rust is not going to do the type conversion for you automatically. If you don't specify it, it won't do it. So in this case, now looking at this example, if you say B is a type of U8, you already understand that this is valid. And then we say A is a U32, and we are passing B, which is a U8 type, into U32. We are going to get an error, right? It's going to give us this error. A is going to say that B is expecting a U32, but found what? U8. And you remember when we had that same error, when we used this as U32, U8, right? Was it this one? Or yes, when we use this as U8 and this as U32, it failed. That's because it cannot perform for you automatic type coercion. So that's the error we got here, and that's the same error about in this one too. So that means the type that you are adding together, or the type you are trying to add into a particular memory space, must be of the same type. And that's what is happening here. We already have U8 here as B, right? So you want to move U8 to U32. It's not going to work because, like I said, the type is expecting is a type of U32. What you can do later is to now typecast or convert this value back to U32. Or once you typecast it, you can now pass it into the U32 and then it will work well. Right? I don't know if that makes sense to anybody. Is it confusing? Do you understand? Is it clear?
Okay, so
I assume that, all right. So I assume there are no questions on that. Okay. So I assume there are no questions regarding that. So I assume that everything we've talked about here is clear, right? So we've covered two things. We talked about syntax, we've covered integers, the variables, right? Let's cover variables a bit, then we wrap up the class for today. But I want us to cover something we can go and start trying on our own before the next class, and then we'll try the exercises too, right? I forgot to mention there are exercises in this book. Like for instance, now this is an exercise for the integer. If you go to this exercise now, you will see what is inside here. Now, what is inside here is the exercise for you to try, right? So this, if you try running this code, it will fail. Let's try it and see. It's going to fail. So how do we fix this? Let me call it compute 2. If I try to run compute 2 from here, compute 2 is taking how many parameters? 2, right? So now the first thing is let's check the parameters first. The function name is correct, the keyword is correct, function name is correct, the parameters are correct, they have the same data type, which is U32, and the return type is also U32. So that means everything at the top here is correct, right? The next thing to check now is change the line below to fix the compiler error and make the test pass. Now, in this case, we don't have a test, but we'll look how test in the next class so that we can have a feel of how it works locally. So, but in this case now, this will not work for many reasons. And I've already shown you an example of why it will not work from when I was adding this to this place, right? But you guys just try to fix it and see. I'm sure it's simple for everybody. So you can go to this integer. Let me drop the link to this on this chat, and I'll drop it on the group also. So I'll drop it on the group, right? Okay. All right, so we have that right here, and sorry, please. Sorry. Okay, so we have we are trying to fix this one, right? We are trying to fix this. So we have a plus b times this. So we remember that this is U32, right? And now we are trying to multiply with a U8 data type. So now let's try running this and see the error we get. Let's just pass in two parameters, 2 and 5. Now this is supposed to be 2 plus 5, that's 7, times 4, that's 24. 8. So if you run this now, it's going to
Odd mass.
you said
Odd mass. You multiply.
board mass. Yeah. Are you sure it's board mass problem alone?
I'm just this was wrong. Like 2 plus 5 times. So
Oh,
that's
okay. Oh, okay. Like the way it should be. Yeah. I get. Sorry, sir. All right. So sorry, I'm coming. You should not call this time, I beg. Okay. So now, sorry, we have the U8 and the U32 type, right? So in this case now, if you write this, you can see the error we get. It says no implementation for U32 times U8, right? And you can see all the other errors here, the warnings or the errors description. It says the traits this is not implemented for this, the following other type implement this, right hand side, blah 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 stuff. So you can see that now. So if we, and also let me add it here, right, 3, so that I won't get that one again. So if I, not obviously this is failing, right? And the reason why it's failing is because you cannot have U32. These are the U32 types. You cannot multiply U32 type by a U8 type, right? So 2 things we can do. What are the first things we can do? Any ideas?
typecast. What do you do?
Which of them? This one?
This yeah.
I've got there. Yeah, so basically it's correct. You just typecast it to U32, and that's all. So you can also remove this, right? And it still work. You get, but like I said, if you do it this way, you're actually making it much more easy for the compiler to know what to do, and you're also managing space more. You get now. So those are the 2 things we can do in this case, and yes, our code will run well. So yeah, the other things you need to know, a bit is the smallest unit of data in a computer, blah blah blah. You already understand that. So let's go to the variables a bit and see if we can talk about them if it's not too long. Okay, so I just want to add variables to whatever we are learning, then we move forward. So now let's talk about variables, right? So the first thing about variables is that in variables, in Rust, right, just like you have in other languages, variables are always used everywhere, every single way. In this case now, we've used variables like this, right? Variable name is res. In JavaScript, for JavaScript, you have, excuse me, we have 2 ways of defining variables, 3 ways of declaring our variables. You have the JavaScript. We have 3 ways, 3 variable. What am I writing? Types. So the first one is what? Const, right? The second one is let. The third one is var. Even though we don't use it anymore these days, but it's still there. It works. So in Rust, variable declaration types are, we have the first one, we have the const, also we have the let, but we don't have the var. Yes. So you can see the similarity between JavaScript and Rust too. Like they are very similar too. There are some things that are similar to JavaScript. If you look at the function type, the function declaration, the types of argument it takes, TypeScript, if you look at this compared to TypeScript, you can see that it's probably always similar to the same kind of structure and stuff. So but Rust has const and let, but it uses the const in a different way. It's similar to how JavaScript const works. Remember that in const type for JavaScript, you cannot modify the variable once you specify it. So it's more like you are tying the variable to that, to the life, for the lifetime of that code. You are tying the variable to the value. So for instance, now if I say something like const number equals to 1, I'm tying this number 1 to this num for throughout the lifetime of that variable. or throughout the lifetime of the scope of that variable. That's the better way to put it. So, but if I use let, I can change the variable, like is available to change. But in Rust, it's slightly different because constant simply means that I can't change it, just like I have in JavaScript. But let also means that I cannot change it until I specify that I can change it. Now, let allows you to change the value of a variable if explicitly declared. But const, you cannot change it. The value of the variable declared with const cannot be changed. And the cannot is going to be stressed in capital letter. In fact, you cannot change it no matter what. But for let, you can modify it, but only if you explicitly say that, yes, I want to modify it. So that's why in this case now, and that is where things like shadowing comes in. One ways to do this, to achieve this, one of the ways are shadowing. One of the ways to do this is shadowing and blah blah blah. So the idea about shadowing now will make sense to you once you understand that let we allow you modify a variable, right? Let we allow you to modify a variable, but const will not allow you to ever modify that variable all through the lifetime of the scope of that declaration. In fact, all through the lifetime of the program. This one is even worse. But for JavaScript, you can modify that variable with outside of the scope of that variable, right? I don't know if that makes sense. But what I mean by the scope of the variable is if I have something like this now, I have something like in JavaScript now, right? I have name function, and then I have another function here called age function, right? Here, I can have const results here as something. I can have it as an object, right? And here too, I can have const result as this, right? But I cannot reassign const to something like this. This will fail, right? And but this is valid. This will fail, but this is still valid. I can use this name res can be reused in this function. Right, I don't know if you understand this now. So this res can be reused in this function. So the idea is that when you have the name function and the age function, you have this res. It can be reused here in this function. It can be reused. And so this is named by the scope. So JavaScript allows you to use const, but in different scopes. But in Rust, once you define a const, you can't use it within this, you can't use it in another scope. You can't even use it in another function. You just assume that you declare it once, it is at. So you always declare const at the top level of your program. You can't even use it inside functions to avoid this kind of thing happening. So const in Rust is a lot more strict. It's very, very strict, stricter than the one you have in JavaScript here. So for let, you can modify it, but except you want to modify this variable. So one way to demonstrate that is if I say let name equal to to fail. For instance, right? I can say name equal to, right? In this case, so this is supposed to work, but it will not work. But if I put it mute, it's going to work, but it will still not work. Sorry, it's going to work rather. Let me not make it confusing. It's going to work, right? So this is a way of like mutating this variable. But if I do not add this mutate to it, I won't be able to pass this to it. It's going to fail, right? Just the same way I can't do it in JavaScript, but that's just an analogy. I hope it makes sense. So what the idea about variables is that you are able to declare variables using let or const. Const is very strict. You cannot modify the value once you declare it. Once you declare the variable, you cannot modify it. But let allows you to be able to modify it, but only when you say that, yes, I want to modify this variable. If you don't specify it to be modified, it's not going to be modified. It will not even allow you to change it. Even though it can change, it will not allow you to change unless you specify it to change. So that's the difference between the two. So you can define your variable using let, Mostly we use let in Rust. So that's what you see here. So in Rust, you can use the let keyword to declare variables. For example, let x equals to 42. Above, we define the variable x and assign it to value 42. Every variable in Rust must have a type. It can either be inferred by the compiler or explicitly specified by the developer. Now, explicit type annotation, you can specify the variable type by adding a colon, followed by the type after the variable name. And that's what we've been doing since. You can see us doing that in different places. Here, for instance, where I explained that you can do it here or you can do it in the parameters. Still the same. So in the example, this example now, we explicitly constrain the type of x to be U32. That means we are saying that this x must be 32 bits type. So that means it must range from, the range, how to calculate it a bit. So that's basically what the range is. So, but in this case now, in case you don't specify, like I said, sometimes you don't need to specify the type. It will just pick it. It will infer the type. Like we have literals the other time. Now, if you don't specify the type of a variable, the compiler will try to infer it based on the context in which the variable is used. So let's say x equals to 42 in this case, right? And let y equals to U32 equals to x. So in this case now, this one can be inferred. So if I do this and I do this here, right, it's going to work. But the moment I specify this type, right, it's going to fail. We tried this the other time and it failed. But the reason why this is working now is because we are not tying this to any data type. So if Rust sees x here, Rust will just automatically map this. Since we did not tie it down to any data type, it will map it to a U32 type and it will work. So that's the difference. So, but inference limitations, the compiler sometimes needs a little help to infer the context variable type based on its usage. In those cases, you get a compilation error and the compiler will ask you to provide an explicit type int to disambiguate the situation. Yeah, so we will see that as we write programs, don't worry. So function arguments are variables too, exactly. So for the arguments you've been using since, you can see that they're also variables. The same way you declare a variable here, it's the same way you use function arguments here. So they are literally the same. Yeah. So so they are variables too, right? So yes. So another thing is when you initialize your variables, you have to use the let, right? You don't have to pass a value to it. When you are initializing a variable, just like we have something like this now, I can do this without passing a value to it. That's basically what they're talking about here. But if I do that, I have to specify the string type. So let's just see the sample first. I won't just be saying it. So if I do this, oh sorry, let me remove this JavaScript stuff that I have here. So name is assigned to value but is never used. So this one now, I can define this variable without specifying a value to it. Right. So and you can see that I can assign the value here. So because it is inferring that it's a string data type, because I didn't specify it here. So it can infer that it's a string data type and it's going to work. So now, but if I try to use a variable before initializing it, let's say for instance now, something like this. Let me just copy this and use it here. If I try to run this, it's going to fail. Right? Because X is used, but I've not initialized it. Don't forget that I only just declared it, right? I didn't pass in any value. I didn't define the value for X. But if I define the value like this, then it's going to work. So there are a lot of rules you just need to know in Rust. That's why it takes a longer time for people to like digest it. But the basic things you need to know are what we've spoken about here. Once you come across these errors, you can always come back to see why it was not working or what can be the reason. Or you can even drop it on the group and ask questions. So that's the idea for this class too. So you get this kind of error and something like that. So now let's look at this exercise again and try to fix this before we wrap up for today. Okay, so we have this kind of function, right? Say giving the start and end point, calculate the average speed. So now let's try to fix this. Let's try to fix this function. Where is it? So we have this kind of function here. Say, given the start and end point of a journey and the time it took to complete the journey, calculate the average speed. So we want to calculate average speed, right? So we gave us the start and the end and the time elapsed. And don't forget that everything is correct. Looking at the top now, there's a function, there's a pub here. Pub is just for visibility, just like you have public, private in Solidity. It's the same thing here, right? So we have the function name, function keyword, the function name. The variables are start, end, and time elapsed. And the data type are the same for all of them. And also the same for the return type, so it's valid. Now, what are we to do here? Define a variable name distance with the right value to get test to pass. And do you need to identify the type of distance, why or why not? So now, let's pass in. Don't forget that we have time elapsed, but we don't have distance here. So let's initialize our distance, right? So distance is what? What type should we give to it? Are we still here? Are we together, please? What type should we pass to this one? We want to make this one pass. We want to make this function pass.
U32.
U32. Should we initialize it? Or we
Yes.
can run it like this.
No. There's no distance.
So if we initialize it like this, yeah, it's going to work. So let's just try this. Facts. I can just do what's the main speed. Okay. So let me just so let me run this.
You haven't added the type to the name.
The type to the name. Oh,
Let's
okay,
name.
okay, this one, yeah. No, I don't really need to have a type. It will still work because don't forget that it can infer the type.
Okay.
Yeah, it can infer the type, but I can still add it like this, and it's still valid too, right? So it's still valid. So it's still going to work still. So if I run this and let's start. I can use variable start. Okay, because you're not using start and end, right? So, but we can use distance. So instead of doing that, we can use distance is end minus start, right? Just to make it. So we can use all the variables inside because that's actually the distance, end minus start. But and we can, I think we even use this function for a lot more stuff, so it can make more sense. Let me remove this y that is here that I'm using. So I remove the errors. Okay, so the speed is 0 because if I say 2 and 3, right? If I make this 30 now, it's going to run because 2 minus 3, 3 minus 2 is 1. 1 divided by 5 is 0. So in this case now, 30 minus 5 is 28. 28 divided by 5 supposed to be 5.3 something. But because remember that it's an integer data type, it will return the decimal part for you. That's why we are getting 5 here. Does that make sense?
Mm-hmm.
Yeah, so that's the idea. So but for this speed also, we can also make some restrictions. We can make some some checks to ensure that if end is if start is greater than end, I want you to panic. End value should be greater than start value. So this is one way to, we've not got it to panic. I'm just putting it out there so we can know that something is what I put. Panic, where are you? So it's just put a macro, right? Expected function. Oh, what did I do? Found macro panic. You're not supposed to put that in there or not? I don't know. Not sure. Okay. Yeah, it's correct. So let's go remove the bracket. Oh, sorry, this is not JavaScript. Okay. So Rust is not familiar with this. It's like Python that doesn't take brackets too. So it doesn't take brackets. So that's the similarity between Python and Rust. Again, there are many similarities between them, a lot. I even wrote an article about it one time. So like 10, 15 similarities among them. But that aside, so if starts is greater than end, return this panic, just panic. So now let's try that. Make this 30 and make this 200. So this should fail. You panic and yes, exit with status 101. So end value should be greater than start value. Now we are using panic here, but there are other ways to do it to get better errors. You can use wrap. Is it wrap? Expect, and try and catch and all of those things. So the yeah, so now we can see we've talked about panic yet, even though we've not gotten to panic true. Or I just wanted to like chip that in so that you can know, because we'll talk about panic soon. We are supposed to mention itself. Okay, we are still coming there, yes, we've not gotten there yet. But we are coming there eventually. So we have the variables. We are going to branching if and else, then we'll go to panics. So we'll talk about panics eventually. So yeah, so that will be the end of today's class. I think this is enough to get started. We've done a lot of things today, trust me. As small as it may seem, we've done a lot. We've covered a lot of things. We've covered integers, variables, functions, return types, strings, print statements, and panic. Even though panic is just to break the code. That's what it means. Just like you're breaking it and saying that panic, everything is scattered, panic. That's all. So this is a basic simple code to do something. You can write other codes like this. You can do a lot of other things, right? And to just work. But that's the point. So I hope this makes sense to everybody. Are we good to go, please?
Yes, I have a question.
Okay, question. Go ahead, please.
Yes, the last this thing you did, I can't see where you specify the divide and the minus you did in the function above.
You mean this one?
Yes.
Okay, no, this one, this is it now. It's there.
Okay.
We are trying to fix the error from this place. It's like an exercise, right? Now,
Yes.
this that I sent, it contains exercises. Now, if you look at it now, it says the exercise for this section is located here. So when I went to this place, I went to the GitHub repo for that. Let me just click.
Okay, I've seen it.
So if I click on this now, you will see it's going to take you to the exercise. You will see the source, go into the source folder, go into the lib folder. You will see this. So you want to make this thing pass, right? Normally we should have run this locally if we're like, but I don't want us to use local setup because we have to install all these things. And I don't know if everybody have set up locally yet. So, but I'm just now copying this function out and trying it here so that we can test it. So, but they said what we need to do is, according to the instruction, they say define a variable name distance with the right values to get the test to pass. Right. So you need to annotate the type of distance, why or why not, and don't change this line below. So we didn't touch this at all.
Okay.
But we know that for this to pass, we don't have the variable name distance because that's why they said define a variable name distance, right? So the first thing we did in our own code is to define a variable name distance.
Okay.
Right. Give it a type, and the type you are giving it is U32 because that's the same type that all of them has here. Do you get? But we're not using the distance to be the end and the start time because that's the distance where you start from and when you stop. That's the distance. So I just subtracting it. So that's what I first did. But then in order to just make the code a bit safe, I added this if statement just to show you how to use if statement and panic because we are still going to talk about it in the other sections. So we are still going to branch in if statement, then we go to panics.
Okay.
So I'm just trying to like show you guys here what you are going to meet eventually. So I added this if statement to show that if the start is greater than the end, it should not be possible, right? So it should just so that's why I added this code and show this. So that's basically what I did.
Okay. Thank
If you
you.
run it, it's passing, yeah. So you're welcome. So you can see that the code passes when we run it, and that's because we have the speed. But currently, it's not going to pass because of the panic. You can see the panic here. End value should not be greater than. It should be greater than start value. So that's why it's panicking. So if I remove this value, make it smaller than the end value, and I run this, it's going to work. So it's no longer panicking. So that's the point. So yeah, so that'll be everything for today's class. So in the next class, we are going to be diving into the branching, the panics, all of these things. Right. And hopefully in the next class, since we're already like conversant with the syntax now, we just dive into panics, factorial branching, loops, so that we have enough time to do a lot of exercises, like break stuff and fix it on our own. I hope that makes sense. Okay, so
Yeah, because
all right, so that'll be all for today's class. Just we spent almost 2 hours, so yeah, in order not to take our day, this is Monday. So yes, thank you very much, everybody. Thank you for making the class, and please try to do the exercises too, right? As much as possible. You can try it on your own. It's not hard. Like if you've done if statement is simple. You can go beyond the class and experiment. So that by the time we get there, you already have an idea. And if you feel like there's a way, there are some things that we need to add that is not covered in this tutorials to make it easier for the next step. You can also point it out. All of us are learning. I'm also learning here, so to make a lot of sense. So yes, thank you very much. I will share the recording once I'm done, and once I get it from Google. Yeah. So that'll be it, guys. Thank you so much for joining once again. See you in the next class, everybody. Have a nice day. Enjoy your Monday. Thank you. Thank you. Thank you.
cheers.
Yes.
Thanks, Chief. Thanks, Chief.
Voila, bro.
Oh boy.